Okay, this is my second attempt at sharing how to create the new Automoblox axle for the IED curriculum. I'm going to do new part, new sketch. I always like to start in the XY plane, but of course it doesn't matter. And so I'm going to just start drawing the half of the profile of this axle as given in the schematics. I'm going to talk about how the schematics are also a little bit incomplete, but I like to start in the middle where the two pieces come together, the two profiles come together. I'll start in the origin. Maybe you'll see what I'm working with here in a second. But this first line will go up the smallest diameter, and I'm only drawing half of this, so it's going to be I'm going to cut it into radius. So we have 0.19 divided by 2. And I'm going to come out to the side here, and I'll fill in the dimensions later. I'm just going to eyeball for right now. Okay, make sure this line right here goes just past the original origin, because it's not supposed to be locked in together. And then when I try and go straight up, it really wants to lock me into either perpendicular to that. It won't let me go straight up, so I'm going to start from the other side. I'm just going to hit escape, go back to line, and now I'll come back to that point. So let me go this way a little bit and back up to the same spot. Okay, the same spot. Okay, so I started with a known value just so I could eyeball the rest of it, that 0.95. But now we can go ahead and add all the dimensions we need. So all our diameters we're going to need to cut in half and make them into radii. So that first one was 0.19 divided by 2. This next one's going to be 0.25 divided by 2. And then we have 0.30 divided by 2. The next one is 0.46, and that one goes up to here. 6 divided by 2. And then we have 0.57 as the last diameter. 0.57 divided by 2 for the radius. Okay, so that takes care of our diameters. Next, we're going to do our linear dimensions. And this year, the good part about the new schematics is they are using datum dimensioning, and all starting from the one side over here. A lot better than it was before. The first one is 0.05. The next one is 0.20, but that one is in reference to the slot that we're going to cut through this later. So we're going to skip over the 0.20 and go to 0.25, which is from this point to this point. And then we have got 0.28. .28. 0.4. That kind of shrunk it up a bit. 0.45. 0.48. 0.81, and the last one is 0.86. Okay, as you can see, this does not turn all of our lines blue because there are some missing dimensions on the schematic given in the curriculum for 2017. So we're going to have to make some assumptions. The first one is this one right here. On the previous curriculum, this was a drop of 0.01. So we're going to keep that at 0.01. Why not? And then these over here, we got 3 more. We need to know how high these go. These two look like they should be the same line. So we're going to use the collinear constraint between these two lines, and that will lock in that one. And then we're not sure, but it looks like this one and this one over here should be collinear. And so we're just going to go ahead and make those two collinear also. And the last one is this line right here. And it's got a few bumps on it in the drawing, but it doesn't tell us how to make those bumps. So we're going to ignore them for now. We're going to use the horizontal constraint between these 2 points. It doesn't look like it's supposed to be exactly horizontal, but we don't really have anything else to go off of. So that will lock it all in, fully constrained. All our lines are blue. We're going to finish the sketch and use the revolve tool. So using the revolve tool, it already automatically selected our profile, so it wants to know the axis. So here's the axis. And that looks all nice and neat. Hit OK. And I've got most of the axle done. Now the last trick is to get those 2 little slots in here. And the slots are rectangles that are 0.04 inches wide by 0.2 inches long. And in order to do that, we need to learn a new tool for my students anyway, which is the tangent to surface and parallel to plane option. So under plane, you pull down that menu, you see tangent to surface, parallel to plane. So we want to choose, we're going to make a plane that is tangent to some surface, and the surface we want to be tangent to is this little ring down here. So we select that. And in the plane we want to be parallel to does not naturally appear in our axle yet. So we need to go to our origin and choose one of these planes to be parallel to. For me, it would be good to be parallel to the XY plane. That will give me the plane I'm looking for right on the edge. So now I'm going to put a sketch plane on that work plane. Start 2D sketch, select the edge of that plane. And now I'm going to project this geometry right here so that I've got a line, a reference line. And I'm going to make a rectangle. And the rectangle, remember, is 0.04 wide this way, it's tall in this case, and 0.2 wide. So I'm going to draw a rectangle freehand. I know that it's going to be 0.2 by 0.04. Okay, so I can still move this rectangle up and down, so I need to lock it in to the center point. And since I projected that line, I can use the horizontal constraint between this point and the center point. I can finish the sketch, and then I'm going to extrude, cut, distance to all, hit OK.